In this video, we're going to start section 7.5 on the expected value. The goal of the section is to calculate the expected value of a function of two random variables using the bivariate lotus and the properties of the expected value. Proposition 7.5.1, bivariate lotus, that's the law of the unconscious statistician. Let x and y be jointly distributed random variables, and let h of xy be a function of x and y. If x and y are discrete and have joint probability mass function p of xy, then the expected value of h of xy is the sum over all x of the sum over all y of h of xy times p of xy. And now if x and y are continuous and have joint probability density function f of xy, then the expected value of the function h of xy is the integral from minus infinity to infinity of the integral from minus infinity to infinity of h of xy times f of xy dy dx. So this theorem looks very similar to the univariate, to the single variable lotus, where you had a function of a single variable as either the PDF or the PDF or PMF, and you had a single variable here, but the idea of multiplying the function of the random variable by the density or the mass function is identical. And in fact, this proposition generalizes to n random variables, x1 through xn, and if they are discrete, they have PMF, p of x1 to xn, or PDF, f of x1 to xn if they're continuous, and function h of x1 to xn. You actually have a version of lotus for as many variables as you have. So in the next video, we're going to do example 7.5.1, where we're going to, I see a mistake here, I'll correct that for the next video, where we are going to apply lotus to find the expected value of a function of two continuous random variables. See you then.